The essential steps to designing a simple compiler for your project. Creating a compiler for your project sounds daunting, doesn't it? Yet, it's such an interesting and rewarding journey. Compilers serve as the backbone of programming languages, transforming human-readable code into machine-readable instructions. Although constructing a sophisticated compiler involves a plethora of intricate details, designing a simple one can be distilled into a series of fundamental steps. Let's dive into the essential components of compiler construction and break down this process into manageable sections. Lexical analysis. The journey of compiling starts with lexical analysis. At this stage, the source code is scanned to convert the sequence of characters into meaningful tokens. This process, known as tokenization, simplifies parsing by identifying language symbols, keywords, and operators. Lexical analyzers also remove whitespace and comments, facilitating a cleaner subsequent process. Implementing this phase often involves creating a finite state machine or utilizing tools such as Lex. Syntax analysis. Once tokens are generated, the compiler moves on to syntax analysis, sometimes called parsing. This step generates a syntax tree or a parse tree to represent the syntactic structure of the token sequence based on the rules of the programming language, syntax. This is where context-free grammars, CFG, come into play. Utilizing parsers like LL, LR, or tools like Yak and Bison can effectively manage this phase, resolving ambiguities and ensuring code adherence to language grammar. Semantic analysis. Following syntax analysis, the compiler proceeds to semantic analysis. This phase ensures the parse tree complies with the language semantics, enforcing rules not covered by syntax alone. During this step, operations such as type checking and variable binding occur, guaranteeing that constructs make logical sense and are valid within the language's domain. Semantic errors are detected and corrected here, maintaining the integrity of the intermediate representation. Intermediate code generation. As compilation progresses, intermediate code generation comes into play. This involves translating the parse tree, or abstract syntax tree, into an intermediate code form, usually representing a low-level language that simplifies optimization and target code generation. This intermediate representation, such as three-address code or static single assignment (SSA), abstracts away specific platform considerations, making it easier to work with across diverse machine architectures. Optimization. The optimization phase seeks to enhance the intermediate code's efficiency without altering its functionality. While optional for a simple compiler, optimization can significantly improve performance or minimize resource usage. Techniques applied might involve reducing redundancy, eliminating unnecessary code, or yielding faster execution paths, benefiting the final executable's effectiveness and speed. Target code generation. In the penultimate phase, target code generation converts the optimized intermediate representation into machine code or assembly code specific to the target architecture. This phase ensures the executable instructions align precisely with the hardware specifics, facilitating the translation from software logic to hardware interpretation. Code generation and assembly. The final phase, code generation and assembly, translates the optimized machine code into binary code, which can be executed directly by the target machine. This involves linking libraries, resolving symbolic references, and producing a cohesive executable file. Conclusion. Designing a simple compiler for your project may seem intricate initially, but by breaking it down into these essential steps, the complexity becomes more manageable. While advanced compilers grapple with more sophisticated optimizations and broader language support, focusing on these foundational phases ensures a robust starting point for developing or understanding compiler technology. Whether for educational purposes or a small project, building a compiler can enrich your understanding of programming languages and machine operation depths. Embrace the process. Happy compiling!